So hi everyone. I will speak today about lesson learned actually installing NI targets on the edge. We'll go from energy management to security and a series of discoveries and tools we've built actually to fulfill, to achieve a project like a year and a half ago. But first, I'm Cyril Gambini, first time at GDevCon. 18 years working with LabVIEW, PC or TFPGA, a little bit of vision, test and version, flex logger when I'm forced to. 17 years working for NI partners and currently working at the NSF Technologies, sorry. And I'm involved in several open source projects. NSF Technologies, founded in 2000, NI partners since 2008. We do system integration, mainly software, a little bit of mechanical and electrical assemblies, automated test system, data acquisition, control, some RT stuff, and we'll talk about it in a few minutes. Hardware in the loop system, and a little bit of vision. And before we dive into the subject, here's a slide for our females that join. Please meet Laurie Kirk, security researcher at Microsoft, conference speaker, industry mentor, and she said something lately. They often do not believe a woman could talk about something technical. Let's make this kind of thing something of the past, and so we should think more about it in our everyday work. Summary. During this presentation, I'm going to talk about dynamic DNS, about VPN, about firewall, a little bit about energy management, and physical logs. I've got many slides, not a lot of time. We've got a booth at the end, so if you want to meet us after, you will find us at our booth. What I'm going to describe is based on an experiment or a project that we did 1 year and a half ago. We had an enclosure with a sbRIO inside. Could be a compact cRIO or a PXI running an NI Linux RT. This is not important. But it was powered using a battery linked to some sensors, and we were doing acquisition every 10 minutes. And the idea was every 10 minutes we were gathering data, making some calculation and pushing over the internet that data back to a server. And the server was doing a lot of things, but saving data into databases, etc. But the part of the project that interests us today is the part on the left. So everything related to the target, battery, sensors, connection to the internet. And we had some requirements, and the idea was to be able to communicate with the targets over the internet. We had to secure and encrypt the communication, try to prevent unattended access, software and hardware, but also preserve the battery energy as much as possible. So since it was connected to battery, the idea was to actually be very light on energy and have a battery life as long as possible. Quick disclaimer. Almost all these requirements were not possible by default with NI Linux RT targets. So we went from surprises to surprises, and we had to be very inventive on that project to fulfill the gaps. And we'll go through some of the problems faced, and we'll see the solution we came up with. First one, how to access the target over the internet. So you may know when you connect a device to the internet, it has a public IP. Often we know the private IP inside our network, but every device has a public IP when it pushes things out on the internet. You have to know the public IP of the target if you want to communicate with it. Sometimes some providers change your public IP over time, and so you have to track it. It's not that easy, and it can be problematic for people. And the other way is to actually register to a dynamic DNS service, and the idea is to access your target thanks to a URL. So we had our enclosure, our sbRIO in there, and the idea was to actually link that sbRIO to a URL. So how to do it? Nothing exists out of the box. We actually came up with a solution that was to use a Python script actually running in the background. Why a Python script and not LabVIEW? Actually, we want to be able to register to the dynamic DNS service, even if we are not using or running any RTXE on the target. So we need to have some sort of service running on the target. And so we found it was easier to do it in Python, actually. We also found out that every dynamic DNS provider has its own way or own API to connect to it and to actually synchronize between your target and the service. We decided to go with NoIP, which is a dynamic provider, which has a HTTP API, or basic calls. All done thanks to the Python script. When you start up the target, the script starts, and it registers to NoIP, and thanks to a URL, you can now access to your target. So the Python script is something that we have at Neosoft Technologies, and if you're interested, you just have to let us know. Second problem we faced: how to encrypt the communication between the internet or even the server and the target. We went through different solutions. We were looking at different protocols. In LabVIEW, you have some TLS support. You have to deal with certificates. Somehow can be somehow complicated if you don't know what you are doing. And you have to think about security before actually programming your application. If you think of security after, you may have to change your code drastically to include security. And because we didn't think about encrypted communication first, we had to change a few things and go back to our LabVIEW scratchpad and modify the code. But before doing so, we actually found out that we could do that encryption thanks to a VPN. So we went on that path and tried to explore that path. So we found out that actually on NI Linux RT, you've got a VPN that is already available in there. You've got an OpenVPN that you can install and run. Problem is OpenVPN is a bit heavy. It's a heavy solution. It's heavy on CPU. It's heavy on bandwidth. So it was working, and you have some knowledge base on a NI website, but it was not ideal. And trying to find another solution, another VPN, we found out that there is WireGuard out there. And WireGuard is actually included into the Linux kernel. And so since we are running an NI Linux RT system, so the idea was maybe we can leverage WireGuard to run it directly on the sbRIO. And actually, we found out that there is a package. So if you do an OPKG list on your target, there is a WireGuard package that you can install. Oh, well, good. We'll try that. We install it. We just start to set it up. It was working until we reboot the target. And when you reboot the target, no more VPN, and you have to redo it from scratch. So we had to actually look at the NI Linux RT code. So it's an open source code, so you can go on GitHub, get the code, analyze what's going on. And we found actually a way to make it start every time correctly, even after the target reboots. So we have special scripts that we leverage now on almost all our NI Linux RT targets to have WireGuard to be active on the target. And what's the beauty of WireGuard? WireGuard actually mounts a new internet interface on your target. So if you designed your application to use unencrypted TCP or UDP connection, all you have to do is target your communication on the IP of that new Ethernet interface, and WireGuard will encrypt everything for you. So you don't have to redo all the communication in your application. You just have to direct your TCP and UDP communication through that WireGuard internet interface. And we were pretty happy with the solution because it comes with a very interesting feature. Actually, with WireGuard, you have to register peers. So you can only communicate between an NI Linux target and a PC, let's say, if they know each other. So WireGuard is restricting who is accessing the target, actually. So if you are trying to leverage WireGuard on a computer that is not known by our NI Linux RT target, WireGuard will just drop the packets, and you don't have to care more about it, and WireGuard will do the job for you, and it will protect, actually, the connection. And WireGuard is pretty lightweight, and for CPU and bandwidth, it works quite well. It's very light. We've been able to stream data at 800 megabits per second through WireGuard using a 9629 sbRIO, so it works quite well. Then we had to find out how to block all connections on the target except required ones. So the idea was to set up a firewall directly on the target. And good news, there is one. There is a firewall installed and active actually on every NI Linux RT target, but doesn't block anything. The way it is set up, the firewall says, hey, you want to come? Come in. You're welcome. Okay. So we found out that we should change that, actually. And we should block everything except required connection. And it was not easy to set up. So firewall that is available on NI Linux RT is named IP tables. And IP tables is kind of hard to set. And you can lock you out of the device. So if you send a bad command, actually, you can actually completely block your SSH connection. You are out of the device, and the only way to restore connection is to actually format your target. So yeah, this is not really useful. So the idea was to leverage IP table, but in an easy way. So we worked on a solution to make it easy. We are LabVIEW developers. We are not Linux gurus, and Linux commands are not really my friends. I prefer to check boxes and draw wires and connect terminals, etc. So the idea was to create a solution that was graphical to actually set the firewall. So here what you see is a dialog that you see into your SSH console. And you can just click the services that you want to actually authorize to go through the firewall. And if you have specific UDP or TCP ports in your application, you can also list them. And behind the scene, a script will set the firewall for you. So for you, it's pretty easy. You don't have to deal with IP tables anymore. The script is doing all for you, and you just have to check what are the services that you want to authorize through the firewall. And so the script will block everything except what you check. Energy consumption. So when I was describing the project, I don't know if you remember that small drawing, but the target is into an enclosure and it's linked to a battery. NI targets are quite energy hungry. I think that NI does a wonderful job doing with sbRIOs and PXI and compact cRIOs, but they are not really prone to reduce the energy they consume. Something we discovered is that it's not possible to put a target to sleep. I don't know if you remember, but we are taking data points every 10 minutes. So for a few seconds, we take data points, make calculation, push that data to a server, and for the rest of the time, we wait until that 10 minutes elapse, and we do it again. So for, let's say, 9 minutes, we do nothing, and when we do nothing with the NI target, it still consumes the same energy as before. So there is no way to actually put it to sleep. We did some benchmarks also on a 9629, and we found out that CPU and FPGA processing influence, of course, the energy which is necessary to power the target, but not that much. So by default, NI target is energy hungry. So we had to find a way to make it less hungry and have the battery to last as much as possible. So we came up with a small device that we created ourselves so that you can put on a DIN rail, and that you put between the target and the battery. So what is that new RTC system doing? It actually keeps track of the time inside of this device, and it communicates, or the target can communicate with the system. And it can ask the system, hey, you should turn me off in 5 seconds. And it will completely turn off the power of the target. But before turning off the power, the target should ask to be woken up in 10 minutes. And so after 10 minutes, the power will be on again, thanks to this device. And since your target is running a RTXE that is set to run on startup, it will be magic, so your code will start again, and it will do the job. And the target itself, once the data points are collected, can ask to be put to sleep again. Since we are stopping the target completely, so the power is off completely, and maybe you know, but the RT part of NI targets is not good at keeping time. It can drift a lot. We have a very precise RTC into the device, and the target can ask the device for the current time and just resynchronize again and to have the current time. So we had to come up with an additional device to actually solve this problem. And last problem, but not least, the target is into an enclosure, but if you have a screwdriver or, if you want to open the enclosure, you will find a way. And so we need to find out a way to prevent access to the physical ports of the target. How do we do this? And after searching quite a lot, we found a solution. We found some locks that we can put inside ports, so USB ports, Ethernet ports. We can even secure SD card ports, your DB9 ports also, and you need a master key to actually remove these locks. So if you want to block the connection, physically block the connection of your targets, even if someone opens the enclosure, the logs are there, and you cannot connect to the NI targets, and so you cannot copy what's inside, So if you have secrets inside, it's kind of protected. We also have logs. It's not shown here in the picture, but we have logs to prevent people from removing an internet cable, an Ethernet cable. And so nobody will just remove the cable and let it there. So once connected, it will stay connected. And so this is something that we have here, and we can demo it if you're interested. But it really enhances physically the security of these targets. And once applied, all these solutions allowed us to enhance security of NI Linux 30 targets, and we were able to deploy the system on the field. And that's it.
Were there any horrible side effects of restarting your RT target 140 times a day?
I was afraid of that, but not that much, actually. And it's even better than I thought, because sometimes we have some newbies doing the RTXE and not matching correctly the memory. And so when you shut down your targets, it saves you, but it's not an excuse. But no. It's a feature, but no real problem. You have to think about the startup time, actually. So when the target boots up and the time it's just load the RTXE and start working, you will spend a minute there. But if you have 9 minutes sleeping, it's that much energy that you can keep into your battery, and so you extend the life of your system.
Your tool that you used for setting the firewall with the checkboxes, is that something y'all made, or was that a tool that y'all found?
No, it's something we all made. Yeah. So we have a Linux expert in the house, but we had to do some research, etc. So the idea was with the firewall was really to provide an easy experience to the end user and to have no excuse to let the firewall open like it is by default. All good.
All right, thank you.
Thank you very much.